streaming today. All right, so we're here to talk about export. Well, the doc is called Export for Training V2. Uh, it's just a working name. Don't read too much into it. The essential, basic concept here is here's my goal. So my goal is to convince the export team that export for training is important, that there are more things you need to do than you are doing today, and to agree that we're going to take on this as scope. I don't want to ship the org chart. So Michael so often tells me that it's bad that compile and export are completely siloed, and a lot of the things we want to do here involve doing more crosstalk, and that's good in my opinion. That's what I want. But I think the main directional point is hey, this is a thing. It's not what you're doing today. I think we should be doing it, and can we blow up the roadmap so that this is a focus. So before I start going over the document, does anyone want to dispute my characterization of the current state of the world? Who we got here? We've got Avik here. We've got Angela here. We've got Sherlock here. Oh, we don't have Yanan. Yanan said he couldn't make it.
Yeah, he had some critical conflict.
Okay. Do we feel like we can collectively make a decision here? As in we actually have the decision makers in the room? Because otherwise this will just be more of an informational thing.
Decision about what?
Well,
About blowing up the roadmap?
well, I mean, I'm saying it in a purposely edgy way to make you guys perk up and listen. But yes, I would want behavior changes. I would want different things to happen than would happen by default. Yes, I'm asking for things. And so I want you to push back, because then we can have a conversation. If you just say, "Oh, this all sounds nice," and then don't change anything, then I have failed at the point of this meeting. So I'll sing you out. Can you make this call?
Uh, I'm probably not completely.
Why
I
not?
I
Who are
I
we
can
missing? Who do we need in this room so that we can make this call?
uh to carve out time from the roadmap to make progress on this thing is definitely possible. Whether that means blowing up the roadmap and what that means for our partners and so on, or other goals, that's the thing that we'll probably have to. I don't think we can finish in this meeting. So on another thing that you mentioned about like silos and whatever, I do think that over the past 6 months there have been lots of developments where it feels like export and compile should come together in more and more ways. Like the export kind of API has stabilized in one sense, like for its past use cases in some sense, but there's a proliferation of new, like precompile being one, um, Dynamo going full graph equals to true in most cases is another one. Exporter package, like multi-graph export, um, more guards needed, or guards need to be enforced. There are many areas where sort of now there's like more of an overlap between compile and export, more than it has ever been there. So think having these conversations and directionally trying to sort of reuse more components and merge some of the work. I think all of that is very justified. and I do think we should be focusing on doing that for the next um, year or so. I'm trying to come together more. I think
Okay,
directionally
but
I
but but
agree
not
with you.
necessarily next 6 months or even next month.
So that's the thing about blowing up a roadmap. I think we should make progress on this. Like we should work on this. How, whether this is like the top priority and everything else gets pushed out. That's the thing that I think we need to think about. Maybe offline.
So help me understand what I'm trading off here. So like, if I make this a top priority and I push a bunch of stuff out, what am I pushing out? What are we like? What are we weighing this against?
Um, well, there are internal commitments around. Yeah, I don't know how much we want to discuss that here, but there are internal teams that are doing launches and so on, and they need support.
Yeah, and they want
Not
things to be
all of this.
exportable. That this is not incompatible with
Yeah.
this, in my opinion. And in fact, like some of the things that I want to have happen would make those teams' lives easier. In fact. Okay, so internal commitments, that's fine. Like we should make sure our partners are happy. I don't is that 100% of the bandwidth?
No, that's not 100%. Um, but yeah, I mean, from what I see every day, there is tons of work that the export team is like basically full of, including even like fixing bugs and things like that. Then there is stuff that we want to do, which is sort of consolidate code or delete code, things like that. That kind of is aligned with this picture, even if it's like at a high level. If you and I discussed this, right? The code is complicated, needs to be simplified. There is an opportunity for simplification because we are like deleting some of the older APIs and so on.
Okay, so I
So
hear
these
I
are
hear
things.
then bug fixes and better engineering, which I also agree
Yeah,
we should keep doing.
yeah.
So we've got external partner commitments, bug fixes, and better engineering. Now am I at 100%?
Bin Sherlock, you want to say something?
I think our focus here is to like export adoption for OSS and focusing more on inference. I think the main if I were to push back, I'm not saying I'm pushing back this like the main pushback I will have is the focus use case of export from training perspective, from your perspective,
Mm-hmm.
and from the traditional usage perspective is pretty different.
Yes. So there's a lift, and like the stock is all about like the delta when you want to go from inference to training.
Right. And our focus now is more on the traditional usage, which is more inference focused. And the focus this have is more like hardening and adoption for both internal and OSS.
Mm-hmm.
And this direction that you're presenting here is it's a big delta. It's not it's not a small delta.
Yeah.
That's why like yeah.
Okay. I'm going to stop roasting people for now. This is a good segue into the first one because I think this will make traditional adoption easier. So let me talk through the first thing. Okay, so this doc is all about you want to do expert for training. What exactly does this look like? And so the very first thing I put here is actually like it's kind of boring actually. It's like sort of like just it's the very most trivial thing, which is that okay, so for the open source people in the room, APS is just one of our internal trainers. Like the details don't matter. We have a lot of trainers internally, and like my problem essentially is for any given model someone is running on APS, can I capture its graph ahead of time? So this is distinct from Torch compile graph capture, which happens just in time, like right when the data gets to me. And I just want it, can I actually reliably do this capture for all models on this trainer? And this is my ask number one. And notice that I'm not asking about this at the point in time when like they finished finalizing the model and they want to go ahead and like now figure out how to deploy it for inference, right? And that's like traditionally when like our partners go in and try to make it exportable, right? No, I want it to happen at the very beginning of the process when people are proposing changes to the model for training.
Yeah. So one caveat here is that, I mean, for APS there is a work stream that does this for training as well.
Yeah, so the IR export for training. And so just to give some context for everyone else, the main motivation behind export for training is solving a backwards compatibility problem, which is that once you finalize the model, you want to just keep that model as is for like any continuous training. You don't want to have to like worry about people making changes to shared components and causing the model to break because someone like made some change to some other component. And in particular, export IR for training doesn't solve the I don't want to compile, I want to compile ahead of time problem, because they only just save the pre-dispatch IR. So like you still have to compile it after the fact if you're using PyTorch 2 for training. And two, it happens fairly late, right? This still happens like once the model goes to prod, right? We don't try to get this to work ahead of time. There is, however, a mechanism, if I understand correctly, whereby when people kick off runs, we do offline attempts to export them and see what happens.
So there, yeah. So there's some projected. We want to launch blob models in the future. We have some idea of doing that. So as people are experimenting, we have these offline jobs just to test exportability. But eventually, like you're right that when people decide that they're going to launch a bunch of models, that's when they go and try to export, and it's not really like in the development cycle that much.
Yes. So what I want is I want to actually propose a very radical change here, which is that so I'm not going to be so radical as to say you're a ML engineer, you're not allowed to like experiment on the model without making sure it's exportable. But I want you to know every step of when you're working on your proposal if you're exportable or not. And I want you to know that you cannot get your change in prod unless it's exportable.
So this kind of thing that you're proposing, like I'm just going to go with what you're saying, but there is the other component of like selling this to the product.
I know this is hard, right? Like I need to find the product group. So I've been talking to some of the AE folks, and they're like, oh yeah, like one problem is there isn't one person. Like every model has its own like process, and so we have to do each of them individually. So right, like to actually make this happen, you have to take steps. Like maybe we have to do this only for one particular MC to start, but like I want to set up this vision, and then I want us to like actually start pulling in this direction. Yes, MPK.
I think APS is also already trending in towards like making sure all components of APS models are exportable. Like they have these like module stability tests that make sure that these are exportable, and we have seen people get stuck because like some modules are not exportable. So I think they would be open to this.
Yeah, the A team is a different kind of beast. If like if we are going to say that model authors and model deployment engineers are separate entities, then this is
No,
not what
no, I
working,
need the
right?
MLEs
Yeah, yeah,
involved. Like I think that is absolutely
yeah.
necessary.
Right. So in any setup where A team is helping deploy something, right? That's already, according to you, it's already too late.
Yeah.
Um,
And
yeah,
like I have the people in AE come to me and they're like, "Yeah, so we're white glove enabling these models, and this isn't going to scale. Like we can't scale this." And also it's like, "Yeah, we've been given this model, we need to export it, and we have 2 days before they want to start training, and like this is just this we can't do this. Like this is not the right way to run the program."
yeah, but the training work stream is different. I think different people are involved than AE. AE is more about the inference side. For training, there is more of a collaboration with the MLEs, as Angela was saying. Uh, but it still feels like the team driving this sort of exportability is sort of a part, like it's still a different team than the group of people who are making proposals, and there is some contract between these two teams. Like when you make changes to your model, you have to satisfy some contracts, otherwise our team has to bear the brunt of things and things like that. So there's like but there's still two teams. Okay, anyway, I think that, I mean, as a vision, I think, and you have to get a vision, then you have to try to push it. So it's believable that we can push it. It's not easy, but whatever.
And let me try to sell this vision some more, right? So this has good effects for not export as well, right? When you can export, so I'm going to use a more neutral term, graph capture. When you can graph capture the entire model, this makes things like training with PD2 compile operationally simpler because now you don't have tons and tons of graph breaks. You don't have people like trying to slug out which of these is dynamic, what the recompiles are. You have one graph, and like you have to understand what the input's dynamism is, I suppose, but it's easy, right? Whereas when there are tons and tons of itty bitty graphs, it's very difficult to figure out what's going on in the model. Okay? And I also have some selfish reasons. So I'm working on auto parallel right now. So to do auto parallel, I need a way to reliably graph capture the part of the model that I want to auto parallelize. But I can't do just-in-time graph capture as torch compile would do, because as part of parallelizing the model, I need to make sharding decisions on the parameters. And depending on how I like make these decisions, I need to like basically say, okay, this parameter is going to be sharded on all these nodes. And this has to happen very early, right? It has to happen before I try to load the checkpoint or initialize the parameters, right? I can't re-shard the parameters later. Well, I can. Like, they actually do this sometimes with the embedding tables. But, like, that's very annoying, and you definitely, like, would not like to be doing that. And I've been, also trying to yank people's leg on this idea of ahead of time precompile, right? Where, instead of something that looks like caching, instead you can like literally run the compiler on one node ahead of time to get a single product. That is what you do for training. And to do that, I need graph capture as well. So like it's not just a like export play, right? Like it affects all of the things we have downstream of graph capture.
Can we go through the rest of the talk?
Yeah,
Oh,
we can.
sorry. Yes, sir.
Go Driss before we go.
I'm more just curious, like in the 5-year horizon, are most work, let's say this exists, are we ahead of time, and are we in an ahead of time world? Is everything ahead of time?
Yeah, I would love in 5 years if everything was ahead of time.
Is that like I don't know, is that like TF? Like, is that TensorFlow 1? I don't know. Like, is that
Yeah. Except
Yeah.
instead of having to manually stitch your graph together, you just wrote normal Python code, and you had the ability to like, be like, it's not graph capturable. I'll figure this out later when you're iterating on like architecture things. And then yeah, I'm just saying, when you deploy, you got to figure this out. And like we still have escape hatches. For example, when we do export for training, we typically don't actually like graph capture the sparse arc, right? Because it's like this very complicated embedding table lookup thing. So instead, we just like black box it as like, this is like at a high level what all the embeddings need to be, and then you still figure that out like as normal code on the other side. You can still do that if you absolutely have to. But yeah, I want to become TensorFlow. No one quote me on that.
So basically, what this comes down to is we are going all in on full graph equals to true. Am I right?
Yeah.
That's the.
And the thing is that like I have an out, right? Like the out I have is, if you can't do full graph equals true, then you can still train your model. You have to use, some of the more goofy deployment mechanisms like the torch package plus AOTI stuff, right? Like you're not completely hosed, but like the gravity should be towards full graph equals true. Like we need to actually be pushing for this.
So are we saying full graph equals to true for all submodules of your model, or are we saying you're still selecting some parts of your model to?
For clarity, the entire model full graph equals true, and then you can like poke holes in this and be like, but Ed, we can't do it in this case, and I'm like, okay, well we'll do it some other way. But like clarity, like entire model full graph equals true. That's the picture. Yes, James.
I have maybe a mini hot take here. How does this compare to a model where, let's say we can do a form of AOT precompile that supports graph breaks, in the sense that maybe it's not as clean as a regular AOT precompile where it's one big callable. Maybe the thing that you're returning is a callable that understands graph breaks in some way. So it knows the state of the graph that was broken when it was first recorded, and then it knows how to navigate that correctly. So there's a little bit more loading time when you have to do something like that, because you probably have to like have that state in some constructed way, but then you can support graph breaks but still be relatively ahead of time. Like, what stops us from building a callable that essentially does that instead of forcing everyone to use a full graph one?
Okay, so the way I answer this question is I look through the use cases and I ask, does this work? So you're talking specifically about precompile, where you get utility out of compiling subgraphs, even if they have to be stitched together. Okay, does this work for export IR for training? So remember, the primary goal here is a self-contained representation of the model being trained, so that you don't have to worry about BC breakage.
Yeah, I guess it doesn't specifically work for that case, but it does work for a lot of the things that you were talking about that you want to unblock, is I guess what I was saying. Because it doesn't generate a full IR, I guess, if you're exporting.
So then let me like take a step back and moderate my stance. I think something like that could be one of the useful tools you have to like get towards the vision. But I wouldn't set that as the vision. Like that is just a stepping stone on the way, in my opinion.
Okay.
And one consequence of like framing it that way is that like if it's very difficult or very complicated, then I think we should be willing to just say no. What's up, Lath?
I lowered my hand, but I was gonna say, is it not possible to represent a set of graphs with graph breaks in export IR? Like, instead of a single graph, you export a set of graphs, and then you have a way also to express the relationships between those. I don't know. It was a stupid question. I
So
don't
the
have a full question, so that's why I lowered my hand.
yeah, exporting multiple graphs with some kind of dispatcher at the top is something that I think exists in some kind of experimental
I don't think
API.
this is what Lath is asking though.
Yeah, but exactly. So I was saying what exists, but not the other thing, which is like in the middle of a graph you have a graph break, and then you have basically multiple graphs and some glue code.
Doesn't
And
super make sense, right? Because if it's multiple graphs with a dispatcher, that just sounds like it's precompile. Because like at that point you're
yeah,
returning like a
exactly. So
binary.
I'm saying that that those two things should merge at some point, but the graph break thing is way more intrusive. And also, who runs the glue code? Is it Python? Is it C++? There's that as well.
All right, Avik wanted us to look at the other things, so let's look at them. These are a lot more tactical. Okay, so here are some of the things that like make export for inference and export for training different. So one of them is partial graph joint tracing / export after AOT autograd. So what is this? So essentially, traditionally export produces a graph, and that's all you get. But autograd is very complicated, right? Because when you do autograd, what you end up running in the end is a forward graph, which runs initially, and a backward graph, which is what actually runs when you're doing propagation of gradients. So, like, the way AOT autograd works is it then traces out a joint graph, partitions it, and then those two get stitched together into an autograd function so you can interact with the rest of PyTorch eager. So basically the ask here is I need to like concern myself with this representation as export. So like if I am auto parallel, I might do a pre-dispatch export, and then I want to then get it into a joint graph because that's what I'm going to work on as an auto parallel solver, right? The joint graph gives me all the compute, and now I can make decisions about what I'm going to shard, what I'm not going to. It's not appropriate to do this earlier because I may need to make different decisions between forward and backwards. If I'm doing precompile, right, like I'm not going to give you pre-dispatch IR. That's not digested enough. I need to have done the autograd stuff, and then I need to compile the forward, compile the backward, paste them together into an autograd function. So to be clear, the work that James Wu and Zheng Shu have been doing, like this is sort of like setting it up so this kind of pasted together autograd function is serializable. But what we haven't really engaged with is like, hey, right? Like we think of export as producing exported programs, which are a single graph. But I need a more complicated data model when I'm doing these more complicated things, where I need more of the internal structure. That's sort of the vibe here. Any questions, comments?
Yeah, so how does this differ from we have an existing API to spit out a joint graph, which was
So which one are you
built
thinking
for-
of?
which was built for federated learning people.
Okay, so there's one API where you can only return a single scalar loss. This in general is not acceptable because in training you're not getting all the way to the end. You might be doing a partial graph with many outputs. There's another API which does the complicated joint thing, but has a bunch of restrictions like no input mutations, things like that. Like all of this needs to work. Like in a general training setting, you need as much feature parity as the regular AOT autograd. So one of the things that I point out here is that like AOT autograd changes the calling convention on the inner graph because like, well, it depends on, Brian can correct me here, but like sometimes you return extra outputs representing input mutations, except we don't do that, I guess, because we put the copy underscores in the graph. Although there's a flag you can toggle in this case. Another like example is just like actually the mutation is the one that I really want to emphasize.
Subclasses are the other big one.
Yeah, so subclass there's like a calling convention change, from the outside, you want to pass in a subclass. From the inside, once you've decomposed it for AOT autograd, it's all expanded out, right? So right now, export thinks of the like input from the very user and the input to the FX graphs as purely something that can be expressed as an input spec pi tree flatten. But like in the more complicated case, this is not necessarily true. Now, it may not be that much work to get there, but that is work that has to be done.
Okay.
All right, let's go to the next one. Validation or guards for export. So what is this? So basically this is you exported the model. How do you know you exported it correctly, right? Like you don't want, the any to be bad. This is like sort of there's a very, very, graphic example for this for auto parallel, which is essentially like a user who wants to use auto parallel is just going to like wrap their model in auto parallel in the same way they would have wrapped it in FSDP or whatever. So if they do that and then the any like is worse, that is bad. Like you really don't want to be using tools that like cause your any to diverge. Like, all our users will go away. They'll say that our stuff is buggy. So we really, really need to get this correctness aspect correct. Historically in export, my understanding is that you export a thing, and then there's like some like downstream pipeline by which people run tests and figure out if it's correct or not. So like maybe that's the right way to do it, but this needs to be brought to the forefront. Like if we're going to like force everything to be graph capturable. And maybe this is not the right thing to do. And so another thing you can do is like actually be serious about guards. Actually evaluate them for real. Because like guards can easily tell you if something has gone wrong or not. So an example that I have that I ran into recently was I exported a model and I tried to run it. And it actually ran all the way through, but I got tons of warnings from the Trident kernels saying that there were D-type mismatches. And I was like, what the heck? Why are there so many D-type mismatches? And the answer is, when I exported the model, autocast was turned on. And I forgot to turn autocast back on when I retraced it. And as a result, all the D-types were wrong. And nothing told me this. I just like ended up like seeing the D-type mismatches, and then I guessed like various autocast invocations until I got the right one. So once again, I don't think this one's that hard to fix, but like this general concept of like, YOLO export, like, in the training context, right? Like people don't typically run unit tests on their graph capture in just-in-time compile. So like there's a delta here. Like you have to get them to do that, or you have to like be a lot more confident that you did the capture correctly. And this also is like bad for export because you guys have been pushing non-strict a lot, and obviously you don't get any guards at all in non-strict here.
So yeah, this I think is a bigger change than what you think. So there are multiple things. Like first of all, export has traditionally only cared about shape guards, and not all the guards that Dynamo has. Even in strict export, but even if you focus on the shape guards, we drop them, a lot of them, right? Some of them are checked, but a lot of them are dropped, which is already a problem. It's very easy to come up with a case where, you might get incorrect results because we don't have. I mean, instead of crashing early, you would go on and produce an incorrect result. So just enforcing the shape guards that we do have the shape environment. We could find a way to store all the shape guards, and then enforce them. But that itself makes us nervous, and some people just want to turn them off anyway, even the existing ones, because they think they have enough tests or whatever, which is their problem. But if we had to even like run the shape guards, it makes us nervous. Like Pian and I have been talking about this for a while. Like, so even that is a thing. Like now we're talking about going beyond that and Python guards, which, as you said, like non-strict doesn't even have but we are talking about strict export anyway here. So, um, it does feel like this is bigger. I mean,
Go Leith.
Yeah, my understanding is some people export with with generic inputs, and so like running the guards is actually not what they want, because they don't want the guards to fail, even if they fail, because they know it's just gonna work out of the box because they trace with a non-contiguous tensor or whatever. But maybe like eventually, once we have a good unbacked support, we can switch to that one, and then at that point we can go back to running the guards. But like, if people are assuming they're tracing with general enough input, like if you fail, well, yeah, we fail, but we know it's gonna work anyway. We don't want to fail this guard, and it's hard to identify which ones we want to drop and which ones we want to keep, right?
Yeah, I definitely agree that unbacked ints for export is like we should be headed there. Yes, Richard.
Yeah, I wouldn't bring up that this is not just a training problem. Like VLM uses Torch compile like export. It like traces out a dynamic shape graph and it assumes it can use this for all like batch sizes. And this assumption gets broken like around once a week. And like we have to debug it and fix it. So like we run into this problem all the time. Like I get that people do want to drop guards, but like there should be some way to put them back, like if people are trying to debug like something that is going very wrong.
I personally have spent 3 hours debugging guards not being guarding.
And I also like don't understand why internal like export AOTI jobs don't run into this problem because we run into it so much with VLM models.
yeah, VLM dropping guards is not cool. I think internally, I think there is more of a culture of like just eager models and testing. They probably
Like VLM tests its models. It's just that like when you add a new feature to VLM, like you're putting in I don't know, a new kernel, like some new control flow, and that just straight up triggers this problem. Like it works in eager, you start a compile, you get site incorrectness, you debug for hours until you find out that it is this problem. But having a guards, like a mode to turn a guards on would just tell you instantly what your problem is.
In general, I tend to believe guards should be the default. And, I also am not sure about handing people the foot gun, because they'll load the foot gun and then shoot themselves in the foot and then complain. We're gonna have the foot gun, but definitely if you don't know anything, we absolutely shouldn't be skipping guards by default. Like you really don't want to be skipping them in that situation.
Yeah, and the situation I think has gone worse because we have done automatic dynamic shapes now. So we don't even ask people to specify what the shapes were. So yeah, you could have pretty complicated guards that are capturing the path, which would error before, but not now.
Okay, let's move on to the next one. So the next one is bytecode support. So the context here is that so we talked about the calling convention change between AOT Autograd and the outside world. But in fact, the calling convention change can also be changed by Dynamo. So if you pass in some complicated object or whatever, right, the way that Dynamo figures out what the input tensors should be is it generates some Python bytecode, which pulls them out and populates the arguments to call into the AOT Autograd wrapped callable. So once again, Expert does this with input-output PyTree spec. This is to be fair, most models will work with PyTree spec. Like in auto parallel, I was worrying about this, and it turned out for all the ones we were doing, PyTree spec was fine. Like they had pretty simple input output at the top level. So why am I putting this here anyway? So one is that I have this general desire, which is that if something works with torch compile full graph equals true, I would like that to work too. but I can't guarantee that when I'm doing PyTree input output spec matching. And the second is that I hear that people are always asking export for multi-method export, and this is like annoying. And I think one of the reasons it's annoying is sometimes those have residual Python side effects that like are difficult for export to model. And Dynamo can like deal with this, right? Because it can actually like replay Python data structure side effects in its bytecode. So like I don't know. This is not as important, which is why I had this lower down in the doc. But like if you're looking for full parity with compile, like I don't see how you're going to avoid doing this.
So when you looked at auto parallel use cases and you didn't see this was a major problem.
Yeah, so we have 3 models, and we looked at the input output SIGs for them, and they all work with PyTree. This is OmniFM v2 and DeepSeek and Llama.
So but somewhere in this doc you made the point. Yeah, it's here, right, where you have submodules, and those submodules could have more interesting input output signatures. You didn't find that either?
We're doing the entire dense model. So like I think you would more likely run into this, for example, in the torch package plus AOTI flow. I don't know if you actually ran into it or not.
The version of this we ran into at some point, I don't know what the resolution is yet, was that you would have denser subclasses that would go between submodules.
Yeah, okay. But you actually don't need... Do you need... Brian, we handle that at AOT autograd, right? So subclass unflattening is an AOT autograd problem.
Yeah.
Yeah. So we don't need bytecode for that, actually.
Yeah, that's right. And from talking to Driss and Daniel yesterday, even the like most vanilla quantization subclass cases aren't going to need any of the like graph boundary subclass work, because the subclass like only shows up inside the graph and not at the boundaries.
Today.
Yeah. So this is like, forward looking, like, it's ticking. Like we can probably ignore it, like, and do it later, but.
Okay. I was going to ask at the end of the meeting what the priority order is, but it looks like
I've tried to order it in the like correct order. Well, I don't know if guards is more important than partial graph tracing. For auto parallel, it's more important for joint graph. But I think you could argue about the order between these two. Yeah, the last one is just some random VMAP thing. I actually talked about this with someone, and was it Angela? Anyway, they were like, "Oh yeah, we probably can make pre-dispatch export work for VMAP." So I was like, "Okay, I'm satisfied." Richard.
I'm not satisfied.
You're not satisfied? Okay.
Let me tell you about the problem. I really want Vic's opinion on this. So the problem is people are in post-dispatch export, you need to materialize a pre-dispatch IR, even if you're just exporting for inference. And now the problem is, like, pre-dispatch IR has a lot less coverage than post-dispatch, like, IR and tracing, just by design. Like, VMAP works with post-dispatch, like things like AutoCast, NoGrad, like, also just work with post-dispatch export. We did add support for those for pre-dispatch export. But in general, like, someone's gonna come along, add a new feature, it will just work with post-dispatch export, it's not gonna work with pre-dispatch export. So requiring people to, like, go through pre-dispatch export, even if they just care about inference, makes it so that, like, all of our lives are a lot harder. My pitch would be to just change the design of, like, post-dispatch export to never materialize pre-dispatch export graph.
And this is like counter to our previous, design discussions, which I remember, which is export should be this pipeline thing where we give you early in the pipeline and then you go further.
Well, you can try to extract something from the pre-dispatch part of the pipeline, but, like, the thing you're going to extract is not very useful sometimes. Like, if you extract that and you just drop the context of everything else, then, like, you have a lossy pipeline. And so I just want pipeline to go all the way through. Because there's not a way to extract everything at the pre-dispatch point, like unless someone goes in and does the work. So yeah, Vic, I'm curious if you have any thoughts on this.
No, I don't, because I don't think I understand the problem.
Sure. Okay.
Um,
Concrete example. Hugging Face calls VMAP somewhere in their code. It just doesn't work with export. That's how we ran into this in the first place. Whoever's exporting using Torch export of Hugging Face only cares about like inference. They only care about the post-dispatch graph. But VMAP works with post-dispatch export. It works if you call AOT auto-write on VMAP. You can call make FX on VMAP, and it extracts to you a usable graph. When you call Torch export, it just chokes on VMAP. The way it chokes is like Torch export is trying to materialize a pre-dispatch graph. When it does the materialization of the pre-dispatch graph, it loses the information about VMAP because support was not implemented for it.
okay. So, okay. But what does post-dispatch export mean in this context? Weren't we always going through pre-dispatch and then decomposing at some point using AOT autograd? So at what point did is it just the act of creating an exported program?
The act of creating a pre-dispatch exported program, stopping the tracing, creating a pre-dispatch exported program, dropping all of your global state, and then resuming from there. The problem is we dropped the global state. The global state is needed to continue tracing.
Interesting.
This is sort of related to the autocast thing, by the way. Okay, I don't need individual solutions for each of these things. So I want to return to the like high level, which is like, can I blow up your roadmap? Maybe we like went through all these and you're like, actually a lot of these we wanted to work on. And you know, I would love it if you told me that actually the delta is not that big. But yes. Another peace offering is compile team. I want to blow up your roadmap a little too, I think. Like I think we have to worry about some of this stuff, honestly. MPK.
I have a question. So if export does this, what does precompile look like then? Would it just call export?
Let me think. So ahead of time precompile should be something like you call export, you call compile on it, and you get out a serializable artifact that is stable and can be loaded. I'm glossing over like a bajillion details, but at a high level, that's kind of what I'd want.
I agree that precompile should, for ahead of time precompile, it should go into export first. That would be the best case scenario. It would be sort of bad if ahead of time precompile went around export to do everything it was doing.
Okay. So the guards thing seems like that should be done anyway at some point. Next, the joint graph thing. I don't know what the gaps are between what we have right now and
There's not too big of a gap. So what auto parallel does right now is it does torch. Well, it can do a torch export and then an AOT module simplify some weird internal function. I want an official API, and I need it to work with dynamic shapes. Those are like the two main blockers. Not blockers, where we're like hobbling through as is right now, but like for release we need it. Yes, Lath.
I have a question. Do you know how often we have graph breaks, and like what's the percentage of models that have graph breaks? And
Tons. And like for example, like the most important models are the ones that tend to have tons of graph breaks too. So like life is hard.
If now graph breaks is a prerequisite, how much effort is that, and who's going to do it?
Well, one claim that I have is if you want IR export for training to succeed, this effort is happening one way or another. And I just want us to front load it. I want us to get the MLEs to front load it.
But do you see that as a risk?
Yeah, it is a risk. Like if I look at the export IR for training, they're like, oh, we exported lots of things. And then you look at the most important model class and the rate is like 30% or something. We was like, we're gonna have to grab the bull by the horns. Like
we don't want to do all these things and eventually not have customers onboarding because like, oh, we're not gonna just avoid graph breaks.
I also have like this. There's also like this a wire, live wire, third rail going on here, which is that like we absolutely will not trace through distributed code because we tried to do that and we wasted like a year on this. So we are absolutely not doing this, and I'm not exactly sure how to negotiate this third rail. Well, I guess I do know, which is that we will export unflattened and then apply distributed after the fact. But this is like problems for like precompile, for example. I don't know how precompile is going to deal. Well, the way precompile is going to deal is you don't do the entire thing. Like I don't know. Like there's a lot of leeway in the middle when you're in the midst of things about how to like get around problems by compromising on one aspect of the vision or the other. But like I like having a super clear vision, and the super clear vision is full graphs everywhere. And then we can compromise from there. Animesh, singling you out for a moment. Does this like matter for a front end compiler?
I think I like the vision. It's just that the buy-in seems very high to me. Like it's not just compiler work. We have to rely so much on other MLEs. And yeah, it has to be priority for them. Like if it's high priority for us, it should be as high priority for them. So like that's one thing. Other thing is I really like no more divergence between export and compile. So
oh yeah, because you're always moaning about inline built-in and then module.
You add one flag, and I have to like deal with like 100 export tests, 100 VMAP tests. Like it's just landing a dynamo flag is really hard. So I strongly like I want to work hard to just remove any divergence. So and I hope this work does not just make it even worse. And other comment is I don't really understand the work. Like I understand the vision, but I don't understand how.
Yeah, because I haven't said what the work is. Like we could easily have a composability session on each of these bullet points.
Yeah.
Well, maybe not this one because this is all like internal stuff, but like the other ones, absolutely.
Yeah. And on blowing up the roadmap, I think like it's priority. I think if this is high priority, we should be able to put something. Yeah, reduce priority or something like that and take this up. So that's not a problem for me.
So when you say you don't want any more divergence, is it basically the kind of thing that VMAP is doing, or I suspect it's way more
So,
than
so Animesh is talking about something a little different, which is
Yeah.
like there's a lot of Dynamo config flags, and you guys like toggle a lot of them when you do export, and also because you're non-strict export. Well, Animesh, does non-strict matter in the case you're worrying about?
No.
Yeah, non-strict is fine. So when you're doing strict export and you're toggling all these config flags, and like it's annoying.
But other things as well, very soon you will want hops to be in here, and then you need divergent path for export and compile to support hops. Um,
Oh, I hope not.
this is an area that I think we should all be interested in. The funny thing is that the export team doesn't want to work on strict export most of the time, which might be contributing this problem as well, which is like leaving things behind.
so
Uh,
so 2 years ago, when like I completely agree, like there were like lot of graph breaks, and that led to this sort of like silent um, like concern with Dynamo that it's not working, and but maybe that's not the case, and maybe we should revisit this.
yeah,
Yeah.
that's a whole other kind of conversation on whether non-strict and strict should just be like we should consolidate to all in on Dynamo, because Dynamo is getting basically graph breaks are less of a problem, way less of a problem. That's one. But as you said, like non-strict being on the side is not that uh, is not affecting this divergence. So
So
I hear what Ed said about toggling flags or whatever, but I don't still understand how that contributes to divergence.
so for non-strict versus strict, like are there other divergences in AOT, autograd, or inductor, uh, or is it just like Dynamo?
What I do know is there's a lot of AOT autograd has a lot of code, a huge number of paths through callbacks even, which are very hard to understand. And because export went through multiple levels of IR before settling on training IR, I would suspect that a lot of that code is actually overcomplicated, and we could simplify that. But that's entirely within the actually no that affects strict export as well, because the way strict export works is that you have Dynamo and then call AOT autograd. So you're pretty much hitting the same code with different flags. And here we're not talking about Dynamo config flags. We're just talking about AOT autograd itself being very flaggy, and it's like now it has to work in four different ways it's called, and it has accumulated a bunch of these flags, and like spaghetti code. I wonder if strict export should just be implemented in a very different way.
So we talked about like this way of like redoing the internals. I still think we should. Like that's
Yeah.
just like one of the steps on the way. Richard?
One last comment I had was we did talk about the differences between export and compile like at the start of the year. I'll just paste the doc in here. Giant table of like differences that we talked about but did not do anything about.
I think this actually covers the doc pretty well. It also talks about dynamic shape specs, which I didn't mention, but that is something that is. Oh yeah, we have taught. I didn't even mention device specialization. Oh.
Device specialization is another topic.
Yeah.
Uh,
This is the export needs more out of compile than compile does.
so we are facing this with like Sherlock and I had a long conversation yesterday about this, about how TorchScript is ahead of export in this area, and it allows you to sort of change behavior of a program later by changing state attributes which were specialized to be constants during export, and how that's kind of really causing people angst. And so we are probably going to have a design extend the programming model to allow you to have sort of like dynamic state attributes which are non-tensors. I don't know how that's going to pan out, so we have to design that and then vet it with Ed and other people, and then go implement that. But and that might solve the device specializing problem in particular. But
Sorry, what exactly is this proposal?
yeah, the proposal is still being written, but part of the thing is that you have conditionals in your code that are all kind of trying to model whether the device is what the device is, and it may not be self.device, it may be some other your own state attribute that you carry in your model. And TorchScript allowed you to have other methods that would do this, set the device and select paths through your program, and it would allow you to retain the conditionals in your program that would be
Okay.
sensitive to these
Yeah,
states.
I understand.
And then export just like can't handle that.
Yeah.
And so
Similar to
sort
the
of
eval
multiple-
train stuff you guys were also dealing with a while ago. All right, we're already 7 minutes over, so I'm going to call it. Thanks everyone for coming.